which laws of physics can be expressed and which can be measured. Makes sense, right? Like F equal to ma involves three physical quantities, right? Force can be expressed, quantified, mass can be, acceleration can be, and you take the help of these three to give you Newton's second law of motion in case of constant mass, right? So makes sense. So option A is correct. B, fundamental quantities can be derived by using other physical quantities. No. Should be other way around, right? Fundamental word itself is fundamental, right? These are the building blocks which will give us any other quantity which is a combination. Better word for that? Derived. So this statement is other way around. Hence, I am going to negate that. C, physical quantity is numerical value times standard unit. Fair enough. Force equals 10 Newton. 10 is the number, Newton is the unit. Makes sense. C, correct. And D, derived quantities can be expressed in terms of fundamental. There you go. The reason why B was wrong is the reason why D is right. Answer A, C, and D. All right, let's see this one. Young's modulus of copper. No idea what Young's modulus means, and best part is don't care either. Who cares? Right now. Young's modulus of copper is 10 to the power 5 Newton per meter square. Clearly in SI. Express it in dyne per centimeter square. Dyne per centimeter square. But there is a hint. If you have no idea what dyne means, there is a hint. Dyne is the CGS unit of force. The moment examiner drops this information, even if you haven't heard of dyne, you can figure it out. Okay? So let's start. I'm dying to know what dyne is. Let's go. 1 Newton. Only Newton. Why am I isolating Newton? Because I think the game is between Newton and dyne. Because centimeter, meter, we have grown up relating, right? So the game is just Newton and dyne. That's all. 1 Newton is not equivalent, exactly equal to 1 kg meter per second square. Do you agree? This is in SI. If I have to convert this SI unit to CGS unit, what am I going to do? I am going to replace each term unit by its CGS counterpart. Okay? And here we go. Let 1 be as it is. Kilogram is 10 to the power 3 grams. Meter is 10 square centimeter. And second square is, well, second square. Turns out this 1 Newton, which is 1 kg meter per second square, gives me 10 to the power 5 gram centimeter per second square, and this is nothing but dyne. I'm guessing plurals is dynes. That's okay. So what do we have here? What we have is 1 Newton is 10 to the power 5 dynes. See? I had no idea, but I could figure it out because I knew this is CGS equivalent of that SI. Correct? Are you with me so far? Is this conversion okay? Let's get on with the problem. The problem says convert this, Young's modulus. Y for Young, let's take the symbol Y. So Y is 10 to the power 5 Newton per meter square. Let's convert. 10 to the power 5 Newton per meter square. The 10 to the power 5 doesn't bother me. Let it be. Newton, 10 to the power 5 dynes. Meter square. 1 meter is 10 to the power 2 centimeters, 100 centimeters. So when you square it, it is 10 to the power 4 centimeters square. Correct? So Young's modulus is 5 and 5, 10. 10 minus 4, 6. 10 to the power 6 dynes per centimeter square. Voila. One last thing. I'm still not sure it's dynes or only dynes. So how about this? Let me confirm that I think it's just dyne. So if you can confirm that, 10 to the power 6 dyne per centimeter square. The idea is very simple. I was not focused on baptizing the CGS unit of force. My focus was on the conversion part. Okay? So I am reasonably sure. I don't think they will say dynes. You know why? Because Newton will not become Newtons, right? So 10 to the power 6 dyne. The plural is still dyne. Dyne per centimeter square. The number of particles crossing a unit area perpendicular to the x-axis in unit time. Good question. Why is it a good question? From now till the end of the physics portion, a good question for me personally is always one which looks fancy, which looks big, which looks like a Goliath, right? So the time is to bring out the David in us. You know? The point is, bigger the question, usually more vulnerable it is. More information is given to you. But it separates the brave from the unprepared. So you know, big deal. Number of particles crossing a unit area. Per unit area, perpendicular to the x-axis. Who cares? Who cares? In unit time. Per unit time. So some number per unit area per unit time is given by capital N. Okay. The formula is given. Minus T. I don't know what that is. N2 minus N1. Alright. N1 and N2 are the number of particles per unit volume. Okay. For the values of X length. Okay. X1 and X2 respectively. Fair. What is the dimensional formula of diffusion constant T? Phew. Looks fancy. Believe me, it is nothing. First of all, number of particles. I get it. SI unit should be mole. For anything number of particles. But you can ignore it in units also, right? I'll tell you why. Because, can you see the number in the LHS is matching with the number in the RHS. There can never be two numbers. There will only be one number. Okay, let me show you. Do you agree that for this equation, for the given equation, do you agree that the net dimension of LHS, dim LHS, should match with net dimension RHS? At least do you agree with me on this part? Correct. Now let's see what the LHS is made of. Right now, you should be absolutely fine in writing this as square brackets. Some number. It's okay. Let it be NO. It's okay. Number. Per unit area. So let's create this particular thing. It's number per unit area. Will it be okay if I write area as L square? Per unit time. Okay. One time. That should be okay. Number of particles crossing a unit area, per unit time. Diffusion constant, I have no idea. If you have no idea, it's because that's you're supposed to find. Let it be. Okay. N2 minus N1. Whose dimension should we take? N2s or N1s? If two things are added or subtracted, they must have same dimension. So in dimensional consistency, a bracket is a unit. If inside there are sum of 10, 20, doesn't matter. They all will have same dimension. Addition and subtraction, not multiplication. addition and subtraction are between same dimensional formulas. So number per unit volume. Very good. So the first term would be number. So NO per unit volume. L cube. Do you like that? I do actually. What about x2 minus x1? Length. So length. Take your time. It's okay, take your time. This is why I told you that you can let the number be number. You don't want to go into the whole mole. Even if you have remained that, there cannot be two numbers in multiplication. Had to be one now. Right? Is this okay? Sure. I'll give you a count of 10, a mental count of 10, and then I go ahead. Now you are in a perfect position to ignore number. Forget about it. So what are you going to do now? You are going to do as follows. LHS will be, trust me, let it be 1 upon. Square brackets, L2T. Nice. Let this be T, which we are supposed to find. We did not take care of the minus sign. Any minus sign is -1. Numerical constant multiplied. Who cares? Forget about it. Then number, ignore that. L3L. So should I say L4? Absolutely. L3 times L is L to the power 4. What do I do now? Cross multiply. Okay. If I do that, I get L2 upon T. There you go. You want me to do it? Fine. I get L to the power 4 upon L2T. That is dimensional formula of D, and the answer is properly written L2 T minus 1. This is the dimensional formula for diffusion constant. What did we learn here? Any scientifically valid equation must be dimensionally consistent. What does that mean? Total dimension of LHS should be matching with total dimension of RHS. What does that mean? Write all the dimensions of involved quantities and then convert them into one master dimensional formula and then match that. What does that mean? Tally mass with mass, length with length, time with time, temperature with temperature, and see. That will give you always the unknown dimension formula you are looking for. In this case, it happened to be diffusion constant, and with the formula answer is L2T minus 1. Okay, so the question says the velocity, symbol V, of a transverse wave on a string may depend on. Now, when I was explaining this concept to you, I told you, forget about the word transverse, forget about the word wave, forget about the word string. Focus on the word velocity. This is dimensional analysis. This could very well be velocity of a supersonic jet, of a sonic cloud traveling with Mach 3. See? Even if you don't get that, who cares? It is velocity. Its SI unit has to be meter per second. Okay? So make sure you maintain this attitude till the last thing. Alright? It may depend on, this velocity may depend on A, length L of the string. Who cares of the string? Length L. B, tension T in the string. Tension is short of tensile force. So what is your takeaway from the second dependent? Force. Third, mass per unit length mu of this string. Can you see the symbol U with some elongated neck in the front? That's the Greek symbol mu. It's pronounced as mu. M-U with double dot on the top. Okay? Derive the relationship formula between them. dimensionally. Okay? So understand the method properly. It's a standard elaborate method and it's really widely used. Okay? How you start is as follows. You start by saying let the formula is as follows. Out of 4 quantities, which 4? Velocity, length, tension, and mass per unit length. Out of these 4 quantities, keep one on the LHS. Anyone. Let's say V. Trust me, no bias towards V. Let V is equal to length L, tension T, and mass per unit length mu, all raised to variable unknown exponents. Let's say A, let's say B, let's say C. Do I know A? No. Do I know B? No. Do I know C? No. Question, sir. Why didn't you put an exponent called D on velocity in the LHS? Come on. If you take D on the LHS, can't you take the dth root? Then everything on the RHS will become A by D, B by D, C by D. Eventually you need only 3, na Papa? Get my point? Right? What do you do now? Now, you replace each symbol by its dimensional formula. Watch. Or, what is the dimensional formula of velocity? Dimensional formula of the velocity is L t minus 1. Do you agree with that? Meter per second length upon time. What is the dimensional formula of length? The L, so square brackets, L. Don't forget raised to A. Dimensional formula of force, T is for force. Now force is mass times acceleration. So ml T minus 2. Don't forget the raised to B thing. Any questions so far? No. Last is mass per unit length. Isn't that mass upon length? Absolutely. So shouldn't it be just m L minus 1 and that's it? Absolutely. Mass per unit length. Are you with me so far? Good. What to do now? Use the law of indices or law of indices. I don't know which is the right way to pronounce it, but you get the drift. So what does the law of indices say? X to the power A times X to the power B is nothing but X to the power A plus B. So when the bases are same and they are in multiplication, you simply add the exponents. That's what I'm going to do. So the LHS is just 1. I will leave it untouched and see what I do now. I'll make only one square bracket. I will write 1m. Now search all the m's. In the RHS, in the 3 multiplicative brackets, search for m's. First one has no m. Second one has m raised to b. Third one has m raised to c. So m raised to b into m raised to c is m raised to b plus c. Do you get what is happening? Sure. Then I will write L. Search for L's. Well, there is a A. Very good. Well, there is a B. Very good. Well, there is a C. Minus C. Minus C. Careful, careful. Check, check, check. Huh? Can you finish the last one for me? Come on. Finish the T for me. First one has no T. Third one has no T. There is only one T and that's minus 2B. Check the algebraic indices operation we are just done with. So what's step 1? Step 1 is expression. Express one quantity in terms of the other quantity's product raised to unknown exponents. What's the second step? Second step is to make sure replace every term, every symbol by its dimensional formula. Third, compact it into one dimensional formula. So what you have is an equation, a dimensional equation if you say. Okay? Now listen to this statement very clearly, which you have heard before. You have LHS equal to RHS. If you want this equation to be making sense, this equation has to be dimensionally correct. What does that mean? That means dimension
LHS has to be exactly same as dimension RHS. What do you mean exactly same? That means if there is a M on the either side, same power. If there is a L on either side, same power. If there is a T on either side, same power. There you go. Equate power by power. Do you agree we will get 3 equations? Come on, I'll give you a head start. Come on, start. Come on, compare them. I'm going to start in a while. You have a head start. Don't look at what I'm doing. Make your own 3 equations and see if you can beat me to it. Come on. Let me compare M. But sir, there is no M in the LHS. There is. If there is an M and it doesn't appear, what does it mean? It's M raised to 0. So first equation, B plus C equals 0. Equation 1. Second, L, 1. A plus B minus C equals 1. A plus B minus C equals 1. Third equation. Well, I can see a minus 1 and I can see a minus 2b. What are you waiting for then? Minus 2b equals minus 1. Here are my 3 equations. Now, there are many ways to solve these 3 equations, but I think let's not be guilty of overcomplicating. Clearly, the third one is an equation agreed, it's an answer to. Clearly, minus minus cancel, that gives you b equal to half. Does it or not? Good. So the first thing which I get is b equals half. Can I box it up? Box it up. And can you please focus on equation number 1? What is b plus c? Well, b plus c is 0. So if b is half, c is minus half. Otherwise, how will they add them and it becomes 0? Do you have any problem so far? B as half and C as minus half? No. You know what I'm going to do now, right? I'm going to substitute these 2 boxes into equation number 2 and get the remainder residual value of A. So now, A plus half minus half equals 1. Half minus half. That implies A plus 1 equal to 1, and that gives me A equals 0. The 3 values are here. Nice. A 0, B half, and C minus half. Why don't you just take a look at the solution of the 3 equations, A, B, and C. Digest it, then I go ahead and I teach you how do you express this answer. Of course, if it's an objective question, you need to figure out examiner's point of view. So I'll give you all possible options so that you're mentally prepared of however the option might look like. Sure? Now let's write the final answer. Don't you think A equal to 0 is pretty nice, huh? What does A equal to 0 means? Yeah, no dependence. That's interesting, huh? Let's do. So we said V equals L raised to A, T raised to B, and mu raised to C. Our values are A equal to 0, B equal to half, C equal to minus half. This is perfectly correct way of writing the answer. Absolutely nobody can challenge this. This is correct. Or L raised to 0. You can let the 0 go, right? Sure? Hold on. E raised to half, mu raised to half. Perfectly correct. Or what is power half? Written as radical sign. What is minus half? Still radical sign in the denominator. How about under root T by mu? Even this is correct. Now there is one warning. F equal to ma. Is this a correct equation? Yeah, Newton's second law. Can you check whether the dimension of the LHS equals dimension of the RHS? Yeah, force MLT minus 2. M A LT minus 2. Of course it does. Can you check F equal to 2ma? Whether this equation is dimensionally correct or not? Well, the dimension of 2 is ignored. Dimension of numerical constants are ignored. So I'm about to give you a standard statement. All scientifically correct equations must be dimensionally correct too. But all dimensionally correct equation may not be scientifically correct. And what is the only area I need to be careful about? Multiplication of numerical constants. So in dimensional formula, if somebody has to express this answer, they should express F proportional to ma or F equals kma, where k is a number. So what am I missing here? Either you write proportional here, nobody can challenge this, or you can tag along a small k here. By the way, this k value can come out to be 1, but the problem is dimensional analysis can never help you figuring out this value. This value can only be experimentally figured out. This is what you call as empirical relationship. Remember empirical word? What's the empirical formula of glucose? C6H12O6 is the molecular formula. Empirical was CH2O because it gives you skeleton, right? That skeleton has a factor of multiplicity. Empirical doesn't do with that. That's similarly here also, it gives you a skeletal formula. It's not the exact formula. Do you understand that? So the final answer format, I've taught you everything which is supposed to be there. Don't worry, I think we'll have one more question to do this and apply what we have just learned. Right now, if I rephrase the steps, first, express one as the multiplication of the other with each one raised to a variable exponent. 2, write dimensional formula of all of them. 3, make RHS and LHS into one term dimensional formula. Next step, compare. Mass with mass, length with length, temperature with temperature, time with time, current with current, whichever has involved. And then solve the simultaneous equations and get the skeletal relationship. This, my friend, is called the method of dimensional analysis.
A square-shaped public park has an area of 400, give or take, plus or minus 0.2 meters squared. Find the length of side of the park. Clearly, nobody is testing here that can you take a square root of 400 or not. Obviously, this is an error problem, correct? So, without further ado, let's get going. I don't think expressing principal value should be a problem, right? That's fairly simple, right? Area is L square. That implies L would be A raised to half. I hope that's fine. So the principal value is 20. Idea is error. The absolute error in area is given as 0.2. But when you are dealing with one quantity expressed as the other quantity raised to something, try to recall how were the errors related. Come on. Good. Relative error delta L by L is exponent times relative error delta A by A. Does this make sense to you? Or delta L, the absolute error upon the principal value. Can I take a it's not even a leap of faith. Can I take a small hop of faith and simply say L is nothing but root 400, that's 20? If you don't mind. So this is 20. Let half be untouched as it is. Delta A is 0.2 clearly given to us, and the principal value of area is 400. Correct? So this gives us this entire 20 goes away with this 20, and the 2 also goes away. So what we have delta L as 0.2 upon 40 or 1 upon 200. Checked. 0.2 upon 40. So one of the two gets cancelled. So what you have is a 0.1 upon 20 situation, right? Which is nothing but 1 upon 200. Or 0.005, because 1 upon 200 is 5 by 1000, isn't it? So 0, 0. Express the answer. L plus minus delta L. This format is expressed as 20 plus or minus 0.005